Alrighty, so subtraction of vectors. We've looked at adding the vectors, and I want to remind you that adding means placing them tip to tail. And when we say tip to tail, I mean there's the tip, right? And we go like that, tip to tail. And then remember the resultant is from there to there, right? And if it's not a right triangle, then we use our
Protractor.
ruler and protractor, right? If it is a right triangle, then we use Pythagoras and we use inverse tan. So stop for 10 seconds and say to yourself, what is vector subtraction? What do you think it means to subtract vectors? Most people, when I show them this, they kind of get, okay, yeah, that makes sense. I'm going from there to there, and then I'm going from there to there. They kind of, adding of vectors is what we call intuitive, right? Like it kind of makes sense.
Isn't it when you're like in the displacement or whatever, and you gotta find like, I don't know, how far you are?
Displacement is very strongly related to subtraction.
Well, it gives you like the hypotenuse of that triangle.
Okay?
You have to like.
You mean work backwards?
Yeah, you have to look back.
You're almost right on there.
But if you knew how far you went, how could you just not know how far you went?
Fair enough. It's not about that. What I think Lucas is saying, if I could put words in his mouth, what he's saying is, if you know one of these and you know the overall result, how do you find out the missing part? Is that what you're kind of saying?
Yeah.
That's pretty good. That's pretty good. And we're going to see that later today. So hold on to that thought. Okay, so I'm not going to tell you just yet, but I'm going to re-explain subtraction to you. Plain old grade 2 subtraction. Minusing. Minusing. No surprise.
Hey.
You said it. If I said to you, 10 minus 6, is that the same as 10 plus minus 6? I think everybody here would agree that that's the same thing, right?
You get the same answer.
Does it mean the same thing?
No, it doesn't.
No, you don't think so? 10 take away 6, or 10 adding a negative 7.
How do you add something that's not there?
What?
Well, okay, then talk about accounting, right? I mean, negatives could be debits, right? Positives could be credits, so you can add it in. Add really means combine, does it not?
Mm-hmm.
And once you've got the idea of negatives, then adding more becomes combining, not plussing. So, minus 6 is the negative of plus 6. So then, could we say, do you think, that subtraction of vectors can be done the same way? And I'll tell you that is true. Okay? When you subtract vectors, you add the opposite. Would you say this is, or add the negative? You don't like that?
I like it though.
Well, I'm afraid it's not going to change this because Lucas doesn't like it.
I mean, she doesn't like it either.
Doesn't matter, man. It's not enough. When you go 10 plus minus 6, you're adding the negative. It's the same for vectors, but the question is, what does it mean? What does the negative of a vector mean, do you think? Like, how do you find negative of 6 is minus 6, right? Minus 6 is the negative of plus 6, and vice versa. Well, what's the negative of a vector?
The opposite direction?
How many people think that's a good idea? She's absolutely right. The negative of a vector simply means the opposite direction. A pretty simple concept. Mathematically, it's a little bit more difficult, but the idea of the opposite direction is pretty straightforward. If I'm going east, the opposite of east is west. The opposite of north is south, and so on. Okay? I'm just going to pause here, and we're just going to do this. You guys jot all that down, and then I'll give some answers while I do a test. The negative of a vector is a vector having the same magnitude, the same length, Lucas. The arrow is the same length, but exactly the opposite direction. Exactly the opposite.
So basically you can just do an addition and switch it?
Exactly. That's exactly what you do. It's exactly what you do. But people, for some reason, struggle with it. Okay, so if vector A is to the right, then negative A is simply
To the left.
to the left. If vector B is up and to the right, like so, well then minus B is down and to the right. People get that, right? That's no problem. Once we start throwing numbers in, then it becomes, you gotta have a bit of a plan here. If vector C is at 0, 1, 0, a direction of 10 degrees, which would be like that, right? Then what's minus C? What direction is it? 190 is correct. How'd you do that? Add 180. What does it mean to, you're driving down the car, or not driving down the car, driving down the street in your car, and you pull a 180, what do? Opposite direction, right? Okay, so you add 180 here. What if it's 300? If it's more than 180 already, you add, or you subtract it, 120. You could, I guess, add 180 and then take away 360. That would work too. Most people get that, no problem. Either add or subtract 180. What about south 15 west? How do you go opposite that? What is it? Did I say something else? South 15 east, opposite direction? North 15 west. How do you get that? South becomes north, east becomes west.
One above it, one above it.
This one here?
At 300.
This one was minus 180. This one was plus 180, right?
180 every.
180 means opposite direction.
If it's over 180.
If it's already over 180, like 300 is, you subtract 180. And if it's smaller than 180, then you add it. Relatively simple. Most people do just fine up to there. Go get a clicker. B. Bit of a trick question, right? Bit of a trick question. 10 meters per second east is the same as 10 meters per second west, or it could be minus 10. The minus implies to the left, the opposite. Okay, minus is west, but it would definitely not be minus 10 west. Okay, a little bit of a trick question. That's fine. Okay.
Oh my God. Are you ready?
If vector x is 25 kilometers an hour at north 30 east, what is minus x? I'm hoping lots of people got this right. Yeah, all right. How do you do it? Just change north to south. East becomes west. Yay, everybody got it.
That one was at least.
Okay, I'm working its way up, right? I'm making it a little bit harder at a time. Okay, so here's the big idea. This is what you need to know. All that other stuff is just sort of, setting the tone. Okay? To subtract, don't even write it down yet. Let me explain. Let me explain it. To subtract vectors, find the inverse of the vector to be subtracted and add it. Okay? So like this. Do I have something to click here? No, I don't. Okay. So, don't add that. Don't write yet. Let me explain so that when you're writing it, you get it. Don't write it yet. I'll give you time, I promise. Kurt, you're writing. Okay, so I have to take the opposite of B, right? So I'm going to go like this. That's minus B, right? I'm going to take A, and I'm going to add minus B, like so. Okay? All I did, it's simple. All I did was take B, flip it, and then it becomes addition. Where's my result? From there to there. So this is A minus B. All you do is take the one you were going to add, flip it, and it becomes subtraction. That's all you do.
So you basically add
I'm adding, I'm going vector A plus minus B, right? Now you can write it down. I'll pause there, I'll let you get that down. you're probably sitting there saying, he made this out to be so hard, that doesn't seem that bad.
No, I feel like you're saying, but it gets more complicated.
Well, a little bit. But it's really not. There's two reasons why I did what I did. One is so you realize, oh, that's not that bad, right? You were prepared, mentally prepared, so it made it easier for you. Plus, there's one more step it's just hard to figure out. This part is easy, right? When I throw it into a word problem, then people say, I don't get it.
What's the frick people say?
Not around me, they don't, but let's do an example and see if you get this.
A equals.
If vector A is 10 meters north and vector B is 15 meters east, what is A minus B? Did anyone see when I clicked ahead there? Oh, what's happening? What's coming? Little clicker quiz to see if you get it. So I'm showing you how to do it. In about 2 minutes, you're going to have to be able to show it back to me. So vector A is 10 meters north, and vector B is 15 meters east. What is A minus B? I'll give you one hint. Which one are you flipping?
West.
That's C.
So you have to go west.
Yeah.
Yeah.
Right? There's your hint.
Oh, so we're changing.
Oh, yeah.
Alrighty, let's have a look. So A is 10 meters north. B is 15 meters west. Oh, not B, minus B. Let's write this as
I put mine
A like that. Minus B like that. If I'm going to make it to scale, this should be a little shorter, shouldn't it? Oh, I made it skinny. There.
Why didn't you just move it over?
I don't know. Okay, so my resultant is from there to there. It's just, what's different about this from yesterday? All I did was flip that. That's the only thing that's different. Why are those guys still talking? Okay, I've been waiting for that question to come for a while.
What'd you say?
Yeah. Mitch, listen, man. Crucial stuff here. Nate asked the question I've been waiting 20 minutes for. How do we know which one to flip? The one that has the negative in front of it. No, you know what, Nate? You were not the only one that had that question. They were just too scared to ask it.
You're lying.
I am not lying. Every year someone says, and usually after this, like a day from now, someone else will say it. Because they weren't listening right now.
So
Okay?
it's like B subtract
It's the if it was B subtract A, you'd subtract the A one, or you'd flip the A one. Simple. Okay, so what do? We're going to go R squared is equal to
X squared plus 15.
15 squared plus 10 squared. Does it even matter what order I do these? Now it just becomes grade 9 math, right? It's just regular grade 9 math now.
X squared equals 25. 325.
Why did you put plus? What?
Ah, okay. I've been waiting on that question too.
Oh my god.
Why do I put plus 15, not minus 15? Well, first of all, if I did put minus 15 there, would it make any difference? No. Great question, though. The negative just tells us the direction. We've now just turned this into, like I said, a grade 9 triangle question. Does it matter whether it's left or right? Not to grade 9 math students. And it shouldn't matter to you. You've done the flip. You just need to interpret it at the end, that's all. So I need to square root of 325, somebody please.
18.
18?
18.
Okay, so 18 meters. Am I done?
Yeah.
No.
Well done with that.
You need an angle.
So that's this under it?
It is no sine 18. When you go plus 10 and minus 15, plus 10 means up, minus 15 means to left, but this is 18 at somewhere in between, which is why we need this angle. So tan minus 1, opposite over adjacent, so that's going to be 15 over 10, and someone help me out here.
I done you.
56?
Okay. So that's going to be north 56 west, right? North and then 56 degrees west. Is there anything new about this compared to yesterday? One small little thing. Flip the one that has the negative sign. It's taken me 45 minutes to talk about that.
45.
Surely it's got to be harder than that. No. Let's see what you know. Okay, let's see how you did. Which one is it?
C.
And most of you got it. Well done. Vector A is north, right? B is 4 meters west, so minus B is going to have to be 4 meters east. That one right there. Good job.
Good dog.
Okay. Here's where it gets weird.
Oh my god, here we go.
Here we go. Okay. So I know I said you got to focus here. Here's where you really got to clear your mind. Don't think about anything else. Phones away. Stop thinking about Angry Birds or whatever else you're doing, thinking about. And listen. Displacement. What does displacement mean? Don't bother writing. Don't put those pencils down. Just listen. This is a non-writing part. Sam Barry, put that pencil down. No writing notes.
How far it's traveled.
How far it's traveled. Would you say how far and in what direction?
Yes.
What does that sound like? How far and what direction? That sounds to me like a vector. And, okay, don't write, just watch. An object is on a number line at an initial position of +3. I'm going to call that xi, position initial.
Okay.
It ends up at a final position of -3. xf. Finest displacement. Everybody in the room can go 1, 2, 3, 4, 5, 6. Maybe I can't. Everyone knows in the room it's -6. Sam, put that pencil down. Just watch.
I know you're writing.
Okay? Everybody knows it's -6, right? The point is not for me to give you a complicated way to figure that out. The point is I'm going to show you how vector subtraction can come up with that in a more complicated situation. I don't want you to do vector subtraction on simple ones. On simple ones like this, I want you to go 1, 2, 3, 4, 5, 6. It's -6, Mr. Van. I'm not going to ask you that question, but I'm going to show you how vector subtraction works here. Okay? You don't even need to write that down.
I need to write it down. What the heck?
Okay. How do I do this? What is vector xi? Don't write, just watch. Vector xi is +3. Vector xf is -3. Everybody with me so far? Okay. Displacement is final minus initial. Those are vectors.
You doesn't read pen.
Probably. +3 looks like this. That's my xi. xf is, don't write, xf is -3. But my displacement is final minus initial. So I have to take this one and flip it. And I have to add it to xf. How do I add it? Tip to tail, which is -3, -3. It's displacement of -6, right?
Yeah.
I just did vector subtraction to figure out this real simple one. This is a complicated way of doing it. I don't recommend it. But But I'm showing you how vector subtraction works.
Okay.
I'm not showing you how to solve little simple rinky-dinky questions like this. I'm showing you how vector subtraction works. Okay, let's take displacement now to a 2D model. This one right down.
Okay.
This is the big daddy question of the day.
Daddy.
A hunter is at an original position of 500 meters east from his truck. He is standing right here. He's skinny,
Hey.
Hey, Nate.
and he's got no hair. He's Nate. He walks for a while and then ends up 750 meters north of his truck. This is his...
Wouldn't his original position be his truck?
No.
So he's out in the bush somewhere? Someone drove his truck.
Really good point. Do we care what likely happened? He likely parked his truck there, walked to there. We don't care. The question says that's where he is when he starts. We're only talking about this small little window of time. Okay? I don't care if aliens abducted him and dropped him 500 meters east of his truck. All I care about is that's where he is at the start. Draw in that XI and that little man there.
What about the truck?
You can draw in the truck if you want. It's up to you. He walks for a while and ends up 750 meters north of his truck, which is there. Did he walk from his truck to there? No. Where did he walk from? He walked from there to there. He walked along this red line. That, my friends, is his displacement. Could you figure out what that D is? Well, of course you could. This is 500 and that is 750. And you could do it without any vector subtraction at all. That's not the point. The point is for you to demonstrate you understand vector subtraction, and when you get to grade 12, I'm going to make it easier for you, but you have to understand what vector subtraction is. This is as far as I'm going here, right? Okay. How do we make this a vector subtraction question? How do we demonstrate vector subtraction using this? The same way we just did with the one dimension. Displacement is final minus initial, right? It's where you ended up minus where you started from. And where we ended up is this one. And where we started from is this one. So which one do I flip, Nate? The 750 or the 500? Which one has the minus on it? The XI. Which one's the XI? This one here. Do I just go 750 minus 500? No. Gotta have No. You gotta deal with the directions. You can't do vector questions without the directions. So I redraw my picture. This is sort of like a diagram of what's going on. Now I'm going to draw a vector diagram, a vector picture. So it's going to be 750 minus xi. So if xi is to the right, then minus xi is to the left. And there is
Do you mean R?
my displacement. D means R in this case.
Okay, well then let me put R.
Is this the same triangle as that? Not really. It's kind of the complement, and it's a bit small. I just drew it smaller, but it could be the same size, right? And now you complete it. I need this diagram to give you full marks for the outcome. Understand vector subtraction. If all you do is this, if you just go d squared equals 500 squared plus 750 squared and solve, then I can't say that you understand vector subtraction. So that's going to be 500 squared plus 750 squared, and then take the square root. 901. And I need this angle. And the angle goes like this. Opposite over adjacent. Opposite is my xi, which is my 500. Yes?
You only have one in
Okay, my friends, do you understand vector subtraction? Time to show me that you've been paying attention. I got question number 4, question number 5, and question number 6. Okay, I've given you the diagram. What is the magnitude of the displacement? Lucas, what does the word magnitude mean?
distance.
The distance, the number part, right? I need it to 1 decimal place.
Oh, I have to work.
We'll be here, bud.
Yay, much better, 1.6. I'm gonna guess one person rounded off wrong, right? How'd you do that? 1.5 squared plus 0.6 squared and take the square root of that, right?
Girl,
I think you get it.
no.
What's the angle of displacement?
How do you tell me?
A, B, C, or D?
First of all, you just do it.